Today I am going to tell you a story. It's about an incident when Team Alpha faced an issue in production that left them high and dry. Once upon a time, Team Alpha adopted a service that was not working as expected. So, they got together to plan a heart surgery. They rewrote the algorithm and tested it. And they happily deployed it. Everything was good. The new estimation algorithm worked like a charm. But within a couple of days the new service fell apart. The service was consuming a lot of network bandwidth. It was sending out data at continuously increasing rate which went as high as 2.5 Mbps. Team Alpha restarted their service as a quick measure. They could see the network traffic went back to zero. Well, the network consumption started creeping up within a few hours, and then they had to restart it again, which made it come back to normal. This continued for a day or so and they kept on restarting it. But soon, they were forced to isolate the service in a separate host. Now, Team Alpha called upon their forensic experts to examine what was going wrong with their new service. First they reviewed the code, and found out where the service was talking to other services over the network. They discovered that they talked to only one external service. So they speculated this communication to be the problem. But why is there so much network chatter? Team Alpha decided to analyze the network traffic by taking the network dump, or TCP dump. This will give them more details about the information going in and out of the service. Their strategy was to take two dumps. One just after restarting the service, and the other when the network traffic was at the peak, both for a duration of 45 minutes. The first dump sized up to 358 megabytes, while the second one was 467 megabytes. Which means a difference of 109 megabytes. Which means Team Alpha was sending data at a speed of 177 kilobytes per second during the peak time. But the monitoring tool would show different speeds. So, this was definitely not the issue. The struggle for Team Alpha was still on. They were getting the network dumps and restarting daily, but they were nowhere near the solution. Until, on day 15, something clicked. Team Alpha was using Datadog as their monitoring tool and, hence their service was sending data to it. Nobody looked into that, until now. This communication could also be an issue. Let us first understand what Datadog is. It is a monitoring tool, which combines metrics and events from different services. It allows to build real-time interactive dashboards. One can also configure alerts for monitoring purposes. Let's now understand some terminologies. A metric is the measurement of a particular characteristic. You can define your own custom metrics in Datadog. For example, you want to calculate the response times of all the outgoing calls from your service. For this, you can create a custom metric and record response times against it. Let's see what tags are. To uniquely identify your metric values, you need to tag them. For example, you can create 3 tags which identify which service you are communicating with. So, combining metrics and tags results in creation of a unique metric. If there are 4 outgoing requests to the same URL, the values would be sent against this metric. So, how does the communication between service and Datadog works? All the services send their metrics to a local Datadog client over UDP. The Datadog client periodically aggregates and forwards the metrics to Datadog. Now, let us see what Team Alpha discovered. They found out that their local Datadog agent was receiving lots of data. The pattern at which it was receiving the traffic was exactly the same at which their service was sending. That means their service was sending all this data to Datadog client. To investigate further, Team Alpha took a memory snapshot of their service, also called as heap dump. On analyzing the memory snapshot, Team Alpha figured out that they were tagging the metrics incorrectly. Do you see the remote URL is tagged with some random string? The tag remote URL is used to identify the URL that is being called. So, it should be a constant string like google.com. Well, this long string is actually an ID that Team Alpha uses to identify each request over the network. That means this tag value will change on every new request, even for the same URL. So, what happens when every time the tag value is changed? It will result in creation of a new metric altogether. For example, first outgoing request will generate a new metric which is sent to Datadog, and, on the next request, it will not use the old metric. It will rather create a new metric because the value for tag remote URL is different in this request, and the metrics keep on increasing as the number of requests keep on coming. The data that is sent to local Datadog client also keeps on increasing. Well, that did explain the continuous increase of network traffic. Team Alpha was right on money this time. Now, Team Alpha had to review the code one more time to find out what was causing this issue, and they found out the culprit line. It is just one line. Are you kidding me? No, that's the truth. Here is that line. Okay, it looks normal. That does not look like it could cause so much trouble, right? Alright, let us see what this line should look like. The method definition for this execute method is this. Do you see the problem here? Oh no. The order of arguments is incorrect. Request ID is being sent as remote URL tag. We just have to order the parameters correctly, and the problem will be solved. That's it? Really? All this trouble, just because Team Alpha had incorrect arguments for a method. What do we learn from this? How could this have been prevented? There were no unit tests around that piece of code. If proper unit tests were there, this would have been caught easily. And, here specific types instead of just strings, in the method parameters, would have really helped. Finally, Team Alpha was able to fix this, and the service lived happily ever after. Thank you.